In this lecture, we'll handle general sequence problems that don't fall directly into AP or GP. These include recursive sequences, pattern recognition, term-to-term rules, and mixed behavior. For example, now this sequence, in this sequence, each consecutive terms depend on the previous term. For example, if the first one is 1, then the next one would be 1 plus 3, 4, and the next would be 4 plus 3, 7, and so on and so forth. In the next near arithmetic in this class, but since we cannot write it in terms of, since it's not written in terms of n minus 1 and d, that's why we're calling it a different sequence. Another example could be, and we may have sequence like this. In general, there are four types of sequences beyond AP and GP. Recursive sequences. In these sequences, the next term depends on the previous term. A famous example is Fibonacci, where each term is equal to the sum of previous two terms. The first two terms are always 1 and 1, and the next term is the sum of previous two, 1 plus 1, 2, and the next one is the sum of 2 plus 1, 3, and 3 plus 2, 5, and so on and so forth. Second type of sequences are alternating sequences. In these sequences, the signs or patterns alternate between even and odd. For example, this sequence. If you notice clearly, the sequence would have positive values when n is an even number, and sequence would be negative when n had odd value. So that's why it's kind of alternate in terms of signs. We have two more types of sequences. The third one is the piecewise sequence. In these sequences, we have different formulas for odd and even terms. For example, we can define a sequence where and it's 2n, and then is e. The last type of sequence we have are functional sequences. Now, these sequences often have a function, maybe a quadratic function, most appropriately. For example, n squared minus 3n plus 2. This is, in general, a functional sequence. Now, the next important step is how you recognize which type of sequence you are dealing with in LCAT. So the first step is to check the differences. Yes, that's it. Just subtract the two terms and check the differences. If you have constant differences like 3, 3, 3, that means it's an AP. If you have differences like 2, 4, 8, which you can turn it into an exponent of something, for example, 2, 2 squared, 2 cubed, that means it's a G. The next step is to check the alternating side. If the sign flips, then you might have a sequence which is negative 1 to the power of n, or which includes negative 1 to the power of n plus 1. And the step 3 is check the polynomial behavior. See if it was like a polynomial. If not, then the step is paused, and the last you can check if so yeah, if it's not AP, GP, there are no alternating sides, it's not polynomial behavior, and the last step is to check for recursion. Recursion means that each subsequent value depends on the previous, the last two terms.